This comparison shows the shift when a full moon coincides with perigee, its closest point to Earth. This is the supermoon. Because its orbit is an ellipse, its distance constantly varies, making the closest moon appear 14% larger and 30% brighter. This system is defined by its predictability. Through a process called tidal locking, the moon's rotation has synchronized with its orbit, ensuring it always presents the exact same face to our planet. This stability extends even to its long-term changes. We can measure the moon's slow drift away from us at a rate of 3.8 centimeters every year, a steady expansion driven by tidal friction in our oceans. Because this two-body system is so orderly, it is easy to view this predictable clockwork as the standard for how all moons must behave. But 5.24 billion kilometers away, deep in the Kuiper Belt, these same laws govern a system with a much more volatile reality. At this distance, the scales of the solar system become apparent through the speed of light. While a signal reaches our moon in 1.28 seconds, it takes nearly 5 hours for light to travel from Earth to Pluto. In an environment reaching just 44 Kelvin, the heat of the sun is incredibly faint. This causes nitrogen, methane, and carbon monoxide to exist as solid ice, coating a world billions of kilometers from the inner planets. This diagram compares our Earth-Moon system to Pluto and its largest satellite, Charon. While our moon is only about 1/4 the size of Earth, Charon is half the diameter of Pluto. In our system, the center of mass, the barycenter, is buried deep inside the Earth's sphere. Because the Earth is so much more massive than the moon, our planet barely wobbles as its satellite orbits. But between Pluto and Charon, the mass distribution is much more even. This forces their shared center of gravity out beyond Pluto's surface, where it floats in the void between the two bodies. These two worlds are mutually tidally locked, constantly facing one another as they orbit a point in empty space. It is a double dwarf planet system. Having two massive bodies at the center changes the gravitational dynamics for every other object trying to survive in their orbit. Surrounding this binary core are 4 much smaller moons: Styx, Nix, Kerberos, and Hydra. These are highly reflective, potato-shaped objects, likely the rubble pile remains of an ancient collision that shattered an icy ancestor, leaving fragments trapped in orbit. Unlike Earth's moon, or even Charon, these 4 tiny satellites are not tidally locked. Because they orbit a rotating binary pair rather than a single mass, they are constantly subjected to a shifting gravitational field. As the distance between Pluto and Charon changes relative to the small moons, the pull on them is never uniform. This uneven pull forces the moons into wild, unpredictable tumbling. Kerberos orbits while tilted at 96 degrees, while Nix rotates almost entirely backward. Without a single, stable center of gravity, a synchronized spin becomes impossible. These moons behave more like cosmic tumbleweeds than the orderly satellites we recognize. If these moons are tumbling through such a chaotic environment, it raises a question. Why don't they eventually collide, or just get flung out into the deep cold of the Kuiper Belt? Viewed from above, a distinct pattern emerges. While their spins are chaotic, their orbital paths follow a precisely synchronized rhythm. This is orbital resonance. They are locked in a 5:3:2 ratio. For every 5 orbits by Styx, Nix completes 3, and Hydra completes 2. This mathematical link acts as a traffic controller for the system. By staying in this precise orbital resonance, the small moons prevent one another from ever drifting into a catastrophic collision course. When we return to the familiar sight of our own Earth's moon, predictable, tidally locked, and stable, the contrast is stark. But the same gravitational laws that allow us to predict our tides are the very same laws driving a chaotic, multi-body dance 5 billion kilometers away. Our quiet corner of space is just one expression of a much more dynamic universe.